Hello students, and in this lecture we're going to continue with looking at trend projection, which is a time series model for forecasting, and finish off with the linear regression, which is an associative model for forecasting. In trend projections, linear trends can be found using the least squares technique. The least squares technique can be found by looking at the formula y equals a plus bx. A is the y-axis intercept, b is the slope of the regression line, and x is the independent variable, y is the dependent variable. This will be made clearer when we calculate and when we look at an example to calculate the values for each of these variables, and then we'll be able to see this in an actual line. So for each variable y, a, b, and x, in order to compute what b is, this is the formula, and in order to compute what a is, this is the formula. Alright? Now, in order to compute what b is, we must know what is x, we must know what is y. We also must compute what is x bar and y bar. This example will provide us with all of the information we need to see the formula and to calculate the value for y, which could be the demand. So let's look at what this table is telling us, what information this table is giving us, right? We have the year, so we're looking at the period 2003 to 2009, and in each year, which is, it's going to give what the time period is. So for x, this is time period 1, 2, 3, 4, 5, 6, 7. Alright? It's the same as 2003, 2004, 5, and thereafter. Demand for each period, which is y, is 74 in 2003, 79 in 2004, and so on. Right? So that's the demand for electric power. X squared is simply you square x. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and thereafter. Xy is x multiplied by y. So 1 by 74 is 74, 2 by 79 is 158, and lastly, I'll give one example again. 3 multiplied by 80 gives us 240. The summation of x is 28, so we add up all of these values here. The summation of y is 692 when we add each of these values here. The summation of x squared is where we add the square root of each of the x values, as can see here, and the summation of xy would be the summation of all of these values here as well. We now have enough information to begin our calculations. Remember, we needed to know the value of x bar and we needed to know the value of y bar. The formula for x bar is denoted by the summation of x divided by n. So this is 28 divided by 7. Recall that 7 is the number of time periods that we are looking at. We get 4. X bar is 4. Y bar is the summation of y divided by n. Again, the summation of y is 692 divided by the total 7, which is the total number of years that we are looking at, and we get 98.86. Now that we know what is x bar, we plug that into the formula to get the value of b, and we plug that in the formula to get the value of a. Alright, so please take your time, pause this video, pull out your calculator, and insert all of the values to ensure that you can see how 10.54 was achieved and how 56.70 for A was achieved as well. Now that we know what is A and we know what is B, we can now plug that into our least squares equation to find out the demand. So let us assume that we are trying to estimate the demand for the year 2010. Alright? Y, which is the demand for 2010, would be equal to A, which is 56.70 plus bx. and B is 10.54 by X. Now remember, X was the time period. So if 2009 it was 7, 2010 will now be 8. So X therefore is 8. Alright, so look at your formula here again. Alright, demand in 2010 is 56.70 plus 10.54 multiplied by 8, which is X, gives us a total demand of approximately 141 megawatts. We are now going to plot this information so that we can see the trend line or observe that trend line. But before we do so, let's further estimate demand for 2011. We know the formula. Y equals A plus BX. What X would be? Well, in the year 2011, X would be 9. So, 56.7 plus 10.54 multiplied by 9 will give us an estimated demand for 152 megawatts. Alright? So we plot that. So how do we plot that? We need to find the intercept, which is A, and then we need to also look at the X value. Alright? And therefore we'll be able to connect the two in order to find our trend line. So our X value, which is for 2011 or year 9, alright, so if we were to go to 2011, go up, and remember that our demand was 152, which is approximately here. So we find where those 2 points are, we put a line, we put a dot, and then we also find where the y-intercept is, which is A equals 56.70. So we simply find in the y-axis where 56.70 is, and we can put a dot there. And then we just connect the two dots, and we get our trend line. We'll actually see this later on in another example. Let's now look at seasonal variations in data. The multiplicative seasonal model can adjust trend data for seasonal variations in demand. Let's see how this is calculated. There are 5 steps in the process. Let's view these steps by looking at an example. We have the month. We have the demand for each month in its respective year, 2005, 2006, and 2007. We are now also able to calculate the average for 2005 to 2007, so the average demand in that period, and then the average monthly demand, which is denoted by 94. So this average monthly demand was calculated by adding all of these, adding the average period demand and divided by 12. We now want to find the seasonal index. The seasonal index, therefore, is equal to the average period monthly demand divided by the average monthly demand. So in this case, for January, the seasonal index for January will be the average monthly period demand, which is 90, divided by the average monthly demand, which is 94. 90 divided by 94 give us 0.957. So that's the seasonal index for if we were estimating demand in January 2008. Alright. Now that we have the seasonal index, it's easy to calculate the expected annual demand for January 2008. So we simply take 1200, which is, let's assume that the expected annual demand is 1200. We divide it by the number of months in the year, and we multiply it by the seasonal index that we computed for that month, and we get 96. So 96 would be the expected monthly demand for the year 2008. Right, this slide just shows us differences in what demand was in 2005, 2006, 2007, and when you calculate the monthly demand for each month in 2008, this is what the line would look like. Let us now look at our associative forecasting model. We now review the linear regression analysis model. It is very similar to the least squares model that we looked at previously. However, we apply this technique when our independent variables changes. So when there's a change in any one of our independent variables, that can be used to predict our dependent variable, which is y, we now would use the linear regression analysis. So we're going to look at the same formula, y equals a plus bx. And let's look at an example. Let us say for this example, we have y, this is our sales, and we have the amount of money that was spent in payroll denoted by x. So this is our y variables, this is our x variables. We can now plot this in order to find a trend line. Alright, so here this is the y-axis and this is a horizontal x-axis. So we're going to plot it accordingly. So when y or sales is 2, the payroll expenditure was 1. So you just find where 1 and 2 meets and you put a dot. I'm going to do it for the next one. When y or sales was 3, payroll was 3, as you can see here. 3 is x, 3 is y. I'll do it for the final one, just for practice. When the payroll expenditure was 7, which is x, sales came up to 3.5, which is y. So you simply find where 3.5 is, which is in the middle of 3 and 4. Also find where 7 is, so that you'll be able to see your dot. So this is the beginning of looking at our trend line. Now, let us assume that we would like to find out, alright, what would be the sales if we were to spend $6 billion in payroll? How would we know what the sales figure would be if we were to spend $6 million in paying our employees? Now, we can calculate it using the y equals a plus bx approach. And we can also use the information from the trend line in order to view or be able to observe that forecast as well. Let's first calculate. In order to calculate y equals a plus bx, remember, we needed to know what x bar is, what y bar is, in order to compute what a and b, the values for a and the values for b are. Alright? So, using the same method that we used previously when we were doing the least squares, I want you to take your time, pull out your calculators and calculate this to ensure that your b would come up to 0.25 and your a would come up to 1.75. We now plug that into the equation. So a is 1.75, b is 0.25, alright, and x is the payroll. Now remember, we were trying to calculate what would be the payroll, right? What would be the sales, so if we were trying to forecast what would be the sales if the payroll was 6 billion. So we just simply plug that into the formula. 1.75 plus 0.25 multiplied by 6, because 6 is our x value here, alright, and we therefore get an estimated of 3.25 in sales. Alright, so again, a is 1.75 plus bx. B was calculated as 0.25 and x, in our case, we said we're looking at if the payroll was $6 million, alright, if we spent $6 million in payrolls, what sales would have been generated? and we are able to see that the sales that would have been generated is 3.25. So recall that we actually did the plot, we plotted the values for each X and Y variables in terms of sale and payroll previously. This here is the intercept, right? The intercept on the y-axis, which is A. So all you need to do is look on the y-axis and see where 1.75 exists, which is approximately around here, 3/4 way between 1 and 2. We can, therefore, the trend line we know begins at that point. And then remember, we look at our last variable that we had, which was 3.5 for when payroll was $7 billion, and that was our last line. And we connect the two in order to get our trend line. Now that we have the trend line, it would have been easy. Instead of calculating, you could have just come to where 6 was, right, to where 6 is in your payroll and come across in order to get what the estimated sales would have been if you spent $6 billion in payroll. Multiple regression is very similar to linear regression. The only difference is that if more than one independent variable is to be used in a model, we now have to extend to a multiple regression model to accommodate these several independent variables. So computationally, it looks like this. Before, we would have had y equals a plus bx. But because we have more than one independent variables, right, we would now have to expand it to accommodate other independent variables. So therefore, this b would be b1 x1. So y would be equal to a plus b1 plus x1. That could be one independent variable, plus b2 x2, whichever is the next independent variable, and so on. So in the previous example, let us assume that sales was dependent on payroll. Well, in the multiple regression analysis, sales now could have been dependent on payroll, plus we can probably look at production. All right, so maybe x2 would have been the number of units produced. However, in modern times, this is usually calculated using computer software, such as you can find this in Excel, or you can also use more sophisticated software such as SPSS. That is the end of this presentation. Thank you.